Okay, good day, grade 9s. This lesson is a revision lesson based on graphs. So let's get started. So it's a revision based on graphs. So currently what we are going to look at, remember, a graph is a visual representation of information. Specifically, it shows you the relationship between the independent variable, which is your x-axis, and your dependent variable, which is your y-axis. Remember, the independent variable can stand on its own, whereas the dependent variable relies on the information from the independent variable. So let's get started. So the first example that I'm going to look at is how to find the equation of a straight line. Remember, a straight line is always in the form of y is equal to mx plus c, right? Y is your y value. M represents your gradient, which is basically the slope of the line, and c is your y-intercept. It's the value of the y-intercept, right? Remember, the y-intercept is the point where the graph cuts or intersects with the y-axis. And to find the y-intercept, you let x equal to 0, and likewise to find the x-intercept, you let y equals to 0. So let's do an example very quickly. Let's say I'm given this graph, example 1. Let's say I'm given this graph. So let's draw a quick sketch of a graph. I have my y-axis and I have my x-axis. And remember, if you ever required to draw a graph, now this is just merely a sketch, but if you are required to draw a graph, you need to use your pencil and your ruler, and you need to make sure that the distance between units is the same. For example, the distance between 0 and 1 should, if you measure that to be 1 centimeter on your ruler, it should be 1 centimeter apart from 1 to 2. Likewise, 2 to 3 should be 1 centimeter apart. And that is how your graph should look accurate. So again, you use your pencil and your ruler. But again, this is just merely a sketch. So I have the coordinate 1 and 5. And I also have the coordinate 5 and 2. And this is a straight line. So again, this is a sketch. So it should appear to be a straight line if you take your ruler, right? So on this sketch, I have two coordinates. This is 1 and 5, and this is 5 and 2. So the first thing we need to do, and the end product, our final answer should be y is equal to mx plus c. So we just merely need to find the value of m, and we need to find the value of c. We can first start off by finding the value of m. Now the value of m is basically the change in y over the change in x. So it's going to be y2 minus y1 over x2 minus x1, right? So we need to identify what is our x1, y1 value and what is our x2 and y2 value. So let's take the first coordinate, which is 1 and 5. Let's name it x1, y1. And let's take the second coordinate, which is 5 and 2, and let's name it x2, y2. So now I'm going to substitute the values of x1, y1 and x2, y2 into this formula of gradient. So this is equal to y2, which is 2, and always substitute with brackets just in case you have a negative value, so it's easier to work with. So we have y2, which is 2, minus y1, which is 5, over x2, which is 5, minus x1, which is 1. And this is equal to 2 minus 5, which is negative 3, over 5 minus 1, which is 4. So the gradient of this line is negative 3 over 4. And this makes sense because this is a decreasing graph, right? It's sloping downwards. The easiest way to remember an increasing and decreasing graph is just draw something like that, like a hat, and write ID. So a graph that looks something like this is an increasing graph, right? As the x values increase, the y values increase as well. Whereas a graph that looks something like this is a decreasing graph, meaning that as the x values increase, the y values decrease as well. It's a decreasing graph. So now we found the value of m. So remember, our standard form is y is equal to mx plus c. We found the value of m, which is negative 3 over 4. So now our equation is y is equal to negative 3 over 4 x plus c. Now the last thing we need to do is find the value of c. So how do we find the value of c? We can use any coordinate on the line. We can either use 1 and 5 or we can use 5 and 2. Let's use this first coordinate, which is 1 and 5. So I'm going to take the coordinate 1 and 5. Remember, a coordinate is always in the form of x, y. X is 1 and y is 5. So I'm going to substitute x is equal to 1 into the formula, and I'm going to substitute y is equal to 5 into the formula as well. So where I see y, I'm going to substitute it 5 in the place of y. Where I see x, I'm going to substitute 1 in the place of x. Right? So it's 5 is equal to negative 3 over 4 plus c. I'm going to solve for c, so I'm going to take this to the other side. C is merely equal to 5 plus 3 over 4, and you can show your calculations, or you can just enter this quickly into your calculator, and that should be equal to 23 over 4. So this is the value of c. So your final answer, I'm just going to write it on the top just to save some space. It's y is equal to negative 3 over 4x plus 23 over 4. That is the equation of this straight line. And again, I did not take a ruler and draw this, but you are going to take a ruler and you are going to draw it. And talking about drawing graphs, to draw a straight line graphs, you just need a minimum of 2 points. You need your x-intercept and your y-intercept. So let's take an example. Let's say they ask you to sketch or to draw the graph which has the equation y is equal to negative 5x plus 2. Right? So you can create a table where you have your set of x values, and you can range it quite reasonable, like negative 2 for the x values. It can be negative 2, negative 1, 0, 1, and 2. And you can find your y values by substituting your x values into the equation and finding your y value. Or the easiest method, as I mentioned earlier as well, you need a minimum of 2 points in order to sketch the graph. So those 2 points can be your x and your y-intercept. Now to find your x-intercept, you let y equal to 0. So it's going to be 0 is equal to negative 5x plus 2. Right? I'm going to make x the subject of the formula. Let me take negative 5x to the left hand side. So it's going to be 0 plus 5x, which is just 5x is equal to 2. Now I divide both sides of the equation by 5. X is equal to 2 over 5. Now you might say, how can I plot a fraction? Well, a fraction is basically a number. 2 over 5 is the same as 0.4. So I look for 0.4 on the Cartesian plane and I plot it. So the coordinate here is 2 over 5 and 0. The y value is 0. Now, to find the y-intercept, you let x equal to 0. So it's y is equal to negative 5. I'm going to substitute 0 in the place of x plus 2. Y is equal to 2, because negative 5 times 0 is 0. 0 plus 2 is 2. So the coordinate is 0, 2. So given just 2 coordinates, I can plot it onto the Cartesian plane. Remember, the Cartesian plane needs to be labeled. The y-axis and the x-axis, you need to use your ruler, and it should form a straight decreasing graph. How do I know it's decreasing? Because the value of m, I can see that this graph is in its standard form, y is equal to mx plus c. It's y is equal to mx plus c. So there's no need to even calculate the gradient, because m is equal to negative 5, so it's a decreasing graph. Okay, moving on from there, the last thing I need to explain to you is what happens when we are required to find the equation of the graph that is parallel to another line. So let's take an example. Let's talk about parallel lines first. So let's assume that these two lines are parallel. Now you might say, why are they parallel? I'll indicate it with arrowheads. Parallel lines, if I take a point on the line and I move down perpendicularly, meaning that this straight line here is 90 degrees, and let's say, for example, this is 3 centimeters. Then I take another random point on the line and I go down perpendicularly. It's also 3 centimeters. So it's equidistant apart. And if it's equidistant apart, it's not going to intersect each other. It's not going to cross each other. So parallel lines never meet. So let's call this line 1 and let's call this line 2. Let's say line 1, and remember, we can just call this f of x or this g of x, which basically means that it's the y value. So let's say this equation is y is equal to, it's an increasing graph, so of course it has to be an increasing gradient, so it's 2x plus 1, right? So let's look at this example. Let's say if g of x is equal to 2x plus 1, right, and is parallel, if g of x is parallel to f of x, right, and f of x is or f of x has a y-intercept of -2, find the equation of f of x. So if g of x, remember g of x is just a fancy way of saying y is equal to 2x plus 1. Why do we call it g of x? It's just so that we can distinguish between two different types of lines. And it's parallel to f of x, which is another line. So imagine there's two lines and they parallel to each other. I'm not too sure what's the distance. I'm just using an example. But they are parallel with each other. So what we learned in class is that parallel lines have the same gradient. They have the same slope. So basically the gradient of g of x, let's call it gradient 1, it's equal to the gradient of f of x, let's call it m2. And the reason for that is because they are parallel. They're parallel lines, right? They both linear graphs and they both parallel to each other. So f of x, the equation of f of x, it's equal to mx plus c, or you can just say y is equal to mx plus c. We know what the equation of the given line is. It's 2, because g of x is in the form of mx plus 2. So the gradient of line 1 is 2. So if the gradient of m1 is equal to 2, it implies that m2 is also equal to 2 because they are parallel lines. And again, I'll emphasize, parallel lines have the same gradient. So I'm going to substitute 2 in the place of m. It's going to be y is equal to 2x plus c. Now we need to find the value of c. So we need one coordinate. So by looking at this question, we can't really see a coordinate in here, but actually it's given. It says that f of x has a y-intercept of -2. So when we talk about the y-intercept, it implies that x is equal to 0. So it's 0, -2. So that's one coordinate. So I'm going to substitute. Remember, a coordinate is always in the form of x, y. I'm going to substitute 0 in the place of x, and I'm going to substitute -2 in the place of y. So it's -2 is equal to 2 into 0 plus c. -2 is equal to c. C is equal to -2. Right? And so I found the value of m is 2, and I found the value of c is -2. So the final equation is y is equal to 2x minus 2. Right? And that is how I find the equation. Now, what if lines are perpendicular? So let's say I have one line and it crosses another line, right? If it intersects with the other line at 90 degrees, these two lines are perpendicular to each other. So we say that line 1 is perpendicular to line 2. So let's say that we have this example, right? Let's look at example 2, right? Find the equation of f of x, right? Given, right, that, right, given that the y-intercept is 3 and f of x is perpendicular to g of x, which is equal to, let's say this is equal to negative 2, let's say negative 3x plus 1. So now, how do we find the equation of f of x? Again, f of x needs to be in the form of y is equal to mx plus c. So, right, in this case, when two lines are perpendicular to each other, the product of the gradients is equal to negative 1. So let's say f of x is line 1, and let's say g of x is line 2. So it means that m1 times m2 is equal to negative 1, because the two lines are perpendicular. Do not get confused between perpendicular lines and parallel lines. Now, m1 is given to us. So, sorry, let g of x be line 1 and let f of x be line 2. So let's say g of x is line 1 and the gradient of line 1 is negative 3. There's no need to calculate it because we can see that the equation is in its standard form, y is equal to mx plus c. So it's negative 3 times m2 is equal to negative 1. Now this is like solving an equation. I need to make m2 the subject of the formula, the gradient of the second line the subject of the formula. So what I'm going to do is, it's very similar to this. It's like negative 3x is equal to negative 1. And I ask you, okay, class, let's solve this equation. What are you going to do? You're going to divide both sides by the coefficient, which is negative 3. So you'll tell me that x is equal to positive 1 over 3, because a negative divided by negative is positive. Likewise, in this case as well, I'm going to divide both sides by negative 3 in order to get rid of the times 3. The inverse of multiplication is division. So negative 3 divided by negative 3 is 1. I'm left with m2, which is the gradient of the second line, which is equal to, a negative divided by negative is a positive, is equal to positive a third. So test to see whether it's correct. I can take m1, which is negative 3, times the new gradient, which is a third, and that's equal to negative 1. Now I have found the gradient of the new line f of x. So I have y is equal to mx plus c, that's the standard form. So it's y is equal to a third x plus c. I need to find the value of c. So I need one coordinate. So if I read the question, it says that the equation f of x has a y-intercept of 3. So it implies that this coordinate is 0, 3. Now I'm going to substitute 0 in the place of x, and I'm going to substitute 3 in the place of y. So let me just get a new page out here as well. So I have y is equal to a third x plus c. I'm just going to continue on this. So y is equal to, so sorry, we have the value of y. We said that it's 3 is equal to a third, and I'm going to substitute 0 in the place of x plus c. So 3 is equal to c, c is equal to 3. So my final equation is y is equal to a third x plus 3. Right? So that is how I find the equation of the graph. Okay, thank you.